In this video, we're going to focus on the isosceles trapezoid. So let's start with a picture. Let's say this is A, B, C, and D. So here's some things that you need to know. First, you need to know that the legs are congruent. So this means that AB is congruent to DC. Now what else do we need to know? The bases are parallel. So the upper base BC is parallel to the lower base AD. Next, you need to know that the upper base angles are congruent. So angle B is congruent to angle C. In addition to that, the lower base angles are also congruent. So angle A is congruent to angle D. Now, because these lines are parallel, BC is parallel to AD, you could view AB as a transversal. And so as a result, these two angles are same side interior angles, or consecutive interior angles. And those angles are supplementary. So we could say that angle A plus angle B, the sum of the measures of these angles add up to 180. Now the same is true for C and D. C plus D will also add up to 180. Now the next thing that we need to talk about are the diagonals. The diagonals are congruent. So AC is congruent to BD. And finally, because we have a quadrilateral, a four-sided figure, the sum of all four angles must add to 360. So A and B plus C and D, all of these four angles must add to 360. So those are some things that you want to keep in mind when dealing with an isosceles trapezoid. So now let's work on some problems. So given this trapezoid, and let's say we have these two diagonals, let's say that AC is 5x plus 4. And let's say BD is 8x. Let me think about this one. 8x minus 8. So with this information, what is the measure of AC? How long is segment AC? That's a terrible looking question mark. So we know that for an isosceles trapezoid, the diagonals are equal to each other. So AC has to be equal to BD. AC is 5x plus 4. BD is 8x minus 8. So now at this point, it just becomes an algebra problem. So let's subtract both sides by 5x, and let's add 8 to both sides. On the left, we have 4 plus 8, which is 12. On the right, 8x minus 5x is 3x. And so let's divide both sides by 3. So 12 divided by 3 is 4. So now we have the value of x. So we can calculate the measure of AC. So AC is 5x plus 4, and let's substitute x with 4. 5 times 4 is 20. 20 plus 4 is 24. So that's the measure of AC in this example. So remember that for an isosceles trapezoid, the diagonals are equal in length. Let's try another example. So let's use the same letters. And let's draw the same diagonals. And let's call this E. So in this problem, BD is equal to 18. And EC is equal to 2x minus 4. And AE is x squared minus 13. So with this information, your task is to determine the length of, let's say, AE. Go ahead and calculate the measure of this segment. In order to do so, just like before, we need to calculate the value of x. So what do we know in this problem? What can we set equal to each other? Well, notice that BD has to be equal to AC. The lengths of the two diagonals must be congruent. So BD is equal to AC. Now AC is the sum of AE and EC. So that means BD is the sum of AE and EC. Now BD we know is 18. AE is x squared minus 13. And EC is 2x minus 4. So now we have a formula that we can use to calculate the value of x. So let's begin by combining like terms. Negative 13 minus 4 is negative 17. So we're going to have x squared plus 2x minus 17 on the right side. Now let's subtract both sides by 18. So x squared plus 2x, and then we'll have negative 17 minus 18, which is negative 35. Now we need to factor this expression. What two numbers multiply to negative 35 but add to the middle coefficient 2? Well, we know 7 times 5 is 35. So which number should be positive, 7 or 5? This is going to have to be positive 7 and negative 5. 7 times negative 5 is negative 35. 7 plus negative 5 adds up to positive 2. So to factor it, it's going to be x plus 7 times x minus 5. And so if we set each factor equal to 0, we have two potential answers for this problem. X could be negative 7 and x can be 5. Now we need to get rid of this answer because that would mean EC would be a negative length. 2 times negative 7 minus 4, that's negative 18. And so that's not going to work. So this is the true value of x. So now that we have the value of x, we can calculate the measure of AE. So that's x squared minus 13. And so it's going to be 5 squared minus 13. 5 times 5 is 25. And 25 minus 13 is 12. So AE is 12. Now BD is 18, which means AC has to be 18 as well, which means EC is 6. And so this is the answer though. AE is 12. Here's another example that we could work on. So let's say that angle A is Y, angle B is Z, angle C is 3x, and angle D is 75 degrees. So with this information, calculate the value of x, y, and z. So let's start with x. Angle C and angle D are same side interior angles. Don't forget that BC is parallel to AD. So angle C and angle D are supplementary. So these two angles have to add up to 180, which means that 3x plus 75 is equal to 180. So let's subtract both sides by 75. 180 minus 75, that's 105. So now we need to divide both sides by 3. 105 divided by 3 is 35. So that's the value of x. Now what about the value of y? How can we find that answer? So since we're dealing with an isosceles trapezoid, which is the title of this video, we know that the lower base angles must be congruent. So that means that y has to equal 75. So now what is the value of z? These two angles, the upper base angles, must be congruent as well. So z is equal to 3x. And x is 35. So z is going to be 3 times 35, which we know it's 105. And so now we have the value of x, y, and z. Now I still have a lot more problems to give you regarding isosceles trapezoids. Now in this problem, AB is equal to 2x squared plus 2, and CD is equal to 4x plus 8. So with this information, find the measure or the length of segment AB. So go ahead and try this problem. Now for an isosceles trapezoid, we know that the legs are congruent. So that means that AB is equal to CD. So we can write 2x squared plus 2 is equal to 4x plus 8. So now let's take everything from the right side, move it to the left. So it's 2x squared minus 4x plus 2 minus 8. That's equal to 0. And 2 minus 8 is negative 6. Now, we need to factor, but before we do that, let's divide everything by 2. And so let me make some space here. If we divide everything by 2, x squared minus 2x minus 3 is equal to 0. And now we can easily factor this. We need to find two numbers that multiply to negative 3 but add to negative 2. And this is going to be negative 3 and positive 1. So we have x minus 3 times x plus 1. And so x is equal to 3 and x is equal to negative 1. Now notice that we could use both answers. So for instance, AB, we said was 2x squared plus 2. And CD was 4x plus 8. So if we plug in 3 into AB, that's going to be 2 times 3 squared plus 2. So 3 squared is 9 times 2, that's 18, plus 2 is 20. And if we plug this into CD, it will give us the same answer. 4 times 3 is 12, 12 plus 8 is 20. And our goal is to find AB, so this is one possible answer for AB. Now, if we use the other value for x, this will give us a positive answer for both segments. Negative 1 squared is 1 times 2, that's 2 plus 2 is 4. And for CD, this is going to be 4 times negative 1 plus 8, which is negative 4 plus 8, and that will give us 4 as well. So we need to include both values of x because they give us a positive segment value. So AB can be 20 or it could be 4. Both answers are acceptable. Now let's talk about how to calculate the area of a trapezoid. Let's say the upper base is 10 units long and the lower base is 20 units long. And the height of the trapezoid, we're going to say it's 8 units tall. What's the area? The area of a trapezoid can be calculated using this formula. It's 1/2 b1 plus b2 times the height. So you can think of it as the average base length times the height. To find the average of something, you need to add two things up and then divide by 2. So what's the average base length in this example? The average base length occurs there, where these two are congruent to each other, and these two are congruent, if it's a regular trapezoid. If it's an isosceles trapezoid, then they're all congruent to each other. So what's the midpoint of 10 and 20? The middle number of 10 and 20 is 15. So if we add up b1 and b2, which is 10 plus 20, and if we divide that by 2, 10 plus 20 is 30, 30 divided by 2 is 15. The average base length is 15. And so if we multiply that by 8, this will give us the area of the trapezoid, which is 120 square units. And that's the answer for this example. Here are two problems for you. Let's say if we have two isosceles trapezoids. Let's say this one is ABCD, and this one is EFGH. Let's say there's a mid-segment for both of them where these two are congruent and those two are congruent. Let's say this is EF. Let's say this is XY. Now for the trapezoid on the left, let's say this is 16 and this is 40. What's the measure of the mid-segment, which we'll call X? Now the mid-segment is basically the average base length. It's the average of these two. So X is simply 1/2 of the sum of BC and AD. So it's 1/2 of 16 plus 40. Half of 16 is 8. Half of 40 is 20. So X is 28. So if you add up 40 and 16, that's 56. 56 divided by 2 is 28. Now let's say if this is 30 and this is 22, what is the value of X? Now, notice a pattern for the first example. What's the difference between 40 and 28? The difference is 12. So 40 minus 12 will give you 28. And 28 minus 12 will give you 16. So what's the difference between 22 and 30? The answer is 8. So 30, that's a terrible looking 8. 30 minus 8 will give you 22. And 22 minus 8 will give you X, which is 14. Now you can use this formula to get the same answer. Now the mid-segment, 22, we could say it's the average of 30 and X. So 1/2 of 30 is 15, and then half of X is just, we can write it as half X. Now we need to subtract both sides by 15. So 22 minus 15 is 7. So 7 is equal to 1/2 X. To get rid of the fraction, we can multiply both sides by 2. So 1/2 times 2 is 1. And so X is 2 times 7, which gives us 14. So there's different ways in which you can find this particular value for X. So now you're familiar with the mid-segment theorem. So the mid-segment, let's say EF, is the average of BC and AD. So EF is 1/2 times BC plus AD. Here's another problem for you. So in this example, let's say that the upper base is 10 units long, the lower base is 16 units long, and you're given the area of this isosceles trapezoid. Let's say it's 52 square units. Your task is to find the measure of AB, which we'll call X. So what is the value of X in this problem? Feel free to pause the video and try it. So what we need to do is change the problem. "16 is AD. This part is 10. If we could find the height and the length of this segment, then we can calculate X, because this forms a right triangle. So let's calculate the height first. And actually, it's easy to see what this is going to be. If we call this Y, then this has to be Y. So Y plus 10 plus Y has to add up to 16. Y plus Y is 2Y. And 16 minus 10 is 6. So 2Y is equal to 6. And if we divide by 2, we can see that Y is equal to 3. So I can replace this with a 3. So now I just need to find H. And the area is 1/2 B1 plus B2 times H. the area is 52 square units, B1 is 10, B2 is 16. And so 10 plus 16 is 26, and half of 26 is 13. So H is 52 divided by 13, which is 4. So now we have the value of H. Now let's focus on the right triangle. So this is 3, this is 4. We need to find x. So we could use the Pythagorean theorem, c squared is equal to a squared plus b squared. So c, the hypotenuse, is the same as x. A is 3, b is 4. 3 squared is 9, 4 times 4 is 16, and 9 plus 16 is 25. So now we need to take the square root of both sides, and the square root of 25 is 5. So that's the measure of AB. X is equal to 5.